Hey guys, and welcome to Summer AP Chem Lecture number 1. Rather than having you go through all of these packets on your own in the summer if you don't want to, I'm going to be giving lectures on all of them here on YouTube/Google Classroom for anyone who wants to watch them. If you're good, if you know this stuff and don't need the lecture, stop, bye. But for you guys who want to go through these, the answers are all in here. And these packets need to be done by the first day of school. So I'd recommend sort of spreading these out. I mean, you can do them all the last day before school starts, and that's fine. All of the answers are in here. I'm going to go through the definitions quickly. The definitions are in your textbook. Remember, it's available online, and the link will be up. So you can get these either from me reading them. I have my notes. Or online. I think they'd be easier to come from the textbook rather than pause. And it's like normal. If you find the definition in the textbook, copy it down, you're good. We're going to go through in small sections, and any problem set that's in your packet, I'll do. There are also going to be problems at the end, and a big review. You'll get your big review answers, and the problems won't be due till school starts. Partway into the school year, maybe 2 weeks. So we've got time on that. Right now, what we're doing are the problem sets in the packet for Chapter 1, and we're doing the notes for Chapter 1, Intro to Chem. We've had some different chemistry experiences so far, and hopefully this is a good one. So we're starting with key definitions, and I feel like you guys know those. Some of you might have heard chem is tri for chemistry, but chemistry is the study of matter and the changes it undergoes. So we're going to be looking at what makes it up, how it reacts, what it does, where patterns occur in what specific elements and compounds do. I like patterns. So what's matter? It's stuff. I love that definition. Matter is stuff. Matter is anything that has mass and takes up space, which is stuff. So we're good there. Properties. We'll talk a lot about chemical and physical properties this year. To me, if I say property, it's what something does. It's something about it. Book says any characteristic that allows us to recognize a particular type of matter and to distinguish it from other types. So it's an identifying characteristic. There you go. Elements. It's the things on the table. Things on the table. I'll put up a link to a nice one for you. 120 known right now. Sorry, 118 known right now. I'm looking behind, trying to read that last number. 118 from hydrogen to oganesson. Atoms are your building blocks of matter. So if you want a definition, of elements, materials that can't be broken down or converted into another substance using chemical means. We'll talk about colliding atoms coming up. Kind of the same idea as taking a glob of Jell-O and getting it to stick to the wall. It stays for a second. You're really cool. Look, the Jell-O's on the wall and it falls off. It's how you make new atoms. Run them together in a collider. Hey, look, a new atom. I'm really cool. And they fall apart. Same idea. That's not chemical means. That's considered to be a physical method and not the same. So we're good there. Molecules, it's atoms chemically bonded together. 2 or more. Good. Hope you know solid, liquid, and gas. The symbols are important. Solid is a small letter S, liquid is a small letter L, gas is a small letter G. We're also going to meet aqueous, lowercase aq, meaning dissolved in water this year. What's important is that solids have definite shape and definite volume. Liquids have a definite volume, but not a definite shape. If I have my water bottle, and it's full of water, and I dump it, the liquid doesn't stay the shape of the water bottle. The liquid comes out and makes droplets, makes a puddle if it were full. So there's going to be a difference there in the definite volume. It might seem like it takes up more space once you're cleaning it up, but it doesn't. And a gas is the least dense state of matter, has no fixed volume or shape. If you hear vapor, like water vapor, that means something that's usually a solid or liquid at room temperature, but has vapor, V-A-P-O-R, aided. It's evaporated. Water evaporates, forms a vapor. So if I say gasoline vapor, you think it through. Gasoline's usually a liquid at room temperature. There's your vapor. So properties of solids, liquids, or gases. Hit pause. Try it on your own. See what you think on solids, liquids, and gases. I'm going to go through. No definite shape or volume is a gas. Definite volume, but not a shape. Liquid, definite shape and volume solid. Flows. This is a tricky question. I get my Gen Chem kids on this one on the gas laws test every year. Flows. You go, liquid flows, like the water flows through my pool. Gases flow also if you think of airflow in a building. I'm recording this in May. It's going to be 88 degrees today, and you guys who have had me for class know that there is not airflow in my room come May. I wish I were in the building with all of you teaching at the end of the school year, except for that fact that my room is probably 112 degrees and smells with no air flow. Both gases and liquids are able to flow. Cannot be substantially compressed. I can stomp on an iron brick until I'm blue in the face and it's not going to get any smaller. I can push on water and it's not going to get any smaller. But if I go get my propane tank filled for my gas grill, the gas in it under pressure, the molecules will get closer together. The volume will be compressed. So gases can be substantially compressed. Takes the shape of its container, liquid and gas. Most dense solid, least dense gas happens to the molecules in a substance when it's compressed. They get closer together. Like anything's compressed. I don't want to take out the garbage. Oh, it's just cardboard boxes. Redneck trash compactor. Stomp. That's what happens to molecules too. Liquids and solids, how do they differ in molecular motion? Liquids move more. Liquids are more free-flowing. And that's a big pattern with states of matter. More dense, less movement. Less dense. The less dense you get, more movement. Solids and liquids are pretty close. It might not seem like it when liquids flow, but solids and liquids density-wise are similar, and gas is just way less dense. It's just way further apart. They're nowhere near. Classification of matter. Pure substance, just one thing. The cool thing about a pure substance is it never changes in composition. If I have 100% pure water, it doesn't matter where I get it, it's always going to be the same. It's always going to be H2O. I just have more or less of it. Matter that has distinct properties and a composition that does not vary from sample to sample. Glucose, I say that and you say bio, you say C6H12O6. I say sodium chloride and a lot of you remember to say NaCl. Always the same. Chemical formulas give you pure substances. There you go. What's not a pure substance? Mixtures. We're coming to those in a minute. Two classes of pure substances, elements, my 118 friends from the periodic table, and the compounds that they make. Elements, all I wrote there was that they can't be decomposed or broken down into simpler substances. Parts make them up. Protons, neutrons, electrons. If you get physics-y below that, you can talk about some quarks. But they're not considered to be substances. Those are building blocks of the atom. Compounds, two or more elements together. The law of definite proportions tells us that the proportions of each atom in a compound will always be the same. It guarantees that water is always H2O. It guarantees your glucose, C6H12O6. It guarantees magnesium oxide, MgO. Consistency with law of definite proportions. Now, to our mixtures, there are a combination of two or more substances. When I talk about a pure substance, it's always going to be the same. If I give you a glass of H2O, 100% pure, and you give me one, they're going to be the same. But if I say, hey, make me some coffee, all right, cool. And you're one of those people that likes to taste coffee. You're going to give me maybe black coffee or maybe coffee with a splash of milk. When I drink coffee, I don't want to taste coffee. I want to taste sugar and creamer and probably vanilla and maybe whipped cream on top and maybe something on top of that. I want to taste sugar, not coffee. But if we ask for coffee, both are that same substance. The difference is the mixture. Coffee then is not a pure substance because you can make it differently than I can. Pure water, we can't make any different. A mixture is a combination of two or more substances with each retaining its chemical identity and properties. If I take sand and I take pepper, I don't know why I would do this, and I dump them together, it's a mixture. Stir it up. You can have mixtures of gases. Air is a number of different gases. Nitrogen, oxygen, helium, carbon dioxide, methane. Mostly nitrogen, but a mixture. Mixtures can be solid as well. Steel is an alloy, a mixture of different metals in solid form. Homogeneous mixtures are mixtures that are uniform throughout. So this coffee in my cup looks pretty uniform. Doesn't even smell like coffee. Kind of smells like vanilla and milk. Doesn't smell like coffee, but there are no pieces in it. It's light brown. I would show it to you, but I would spill it on my computer. It is light brown. It's a very nice color. Mixture, yes. Homogeneous, same throughout, yes. When I think of heterogeneous mixtures, I think of chunky. And that's disgusting. Chunky is a terrible word. But I think of pieces that you can see. Homogeneous mixtures like this are uniform throughout. Heterogeneous mixtures are not uniform throughout. They're not the same. You can see pieces. I think of chicken soup. I think of oatmeal. I said last year I think of baked beans, and I had people in the class who had never seen baked beans before. So if you haven't, Google baked beans. It's this reddish brown liquid with beans in it, and sometimes bacon if you're lucky. Mixture, also called a solution, is homogeneous, and we're on to the first problem set. So pause. Classify each of these as an element, a compound, homogeneous or heterogeneous, and I'm going to go through and do them then. So pause and try. All right, cobalt. Cobalt is on the periodic table. Cobalt is also in my fish tank. He's blue. If you had me for class last year, he's my blue fishy. Cobalt's an element. Right off the periodic table. 117 to go. Blood. If you look at blood is similar in composition if you just look at a droplet of it. But if you were to look at blood under a microscope, you'd see cells and you'd see liquid. You'd see a number of different kinds of cells. Blood is a heterogeneous mixture because of the solid and liquid parts. That's a bio thing. Soil, if you dig in the dirt, you'd like it to be as similar as it can, but there are rocks and there are bigger pieces making it a heterogeneous mixture. I had dug in the dirt all weekend. I know the dirt. Prepared Kool-Aid. I was specific because Kool-Aid powder does look all the same to me. But maybe not. Maybe if you've got chunks. But if I prepare this Kool-Aid and get it all ready, my prepared Kool-Aid is whatever Technicolor I want it to be. So it's the same throughout. I hope there aren't chunks in your Kool-Aid. Sucrose. Sucrose is a disaccharide, 2 sugar rings, kind of like 2 glucoses hooked together, just rearranged a little. It's a compound. Sucrose is table sugar and will always be the same. Air, I mentioned when I talked about mixtures. It's a bunch of different types of gases, but like I said, if you've got chunks in your Kool-Aid, you've got a problem. If you've got chunks in your air, you've got a bigger problem. There's bugs or smog or something. That ain't air. Silver, periodic table, an element. I mentioned steel already as a mixture of metals. Bronze is another example of a metal alloy. You still don't want chunks. You want it mixed well. And a homogeneous mixture. Cereal and milk. Love it. Breakfast time. I definitely see, if I don't see chunks in that, I got a problem. I ran it through a blender or something. Carbon dioxide. Chemical formula CO2. If I've got a chemical formula for it, I'm pretty assured that it's a compound. Tungsten. And if you better get used to my writing. If you haven't had me for class before, dig into this writing. It's terrible. If you ever can't read it in school, just ask. Or email me here, and I'll read it. Tungsten's an element. And like I said, coffee. I'm going to talk about not like the pretty coffee, not like the really good coffee where you can see the caramel and you can see everything in it. In general, coffee is the same throughout and a homogeneous mixture. And there is your first question set. Next time through, we'll do properties of matter, separation of mixtures, and the scientific method.